In this video, I'm going to show you how to calculate the concentration. So the question is saying, calculate the concentration in mole per decimeter cube of sodium hydroxide, which is this one here. If 250 centimeters cubic of a solution contains 2.0 grams of sodium hydroxide, where the mixture of sodium hydroxide, which is 40. So one thing you need to know is that concentration is represented by capital letter C, or we can use capital letter M, which is the molarity. So concentration and molarity, they are the same. So it is given by the number of moles over the volume. So the number of moles should be in moles, then the volume should be in decimeter cubic. So from this question, we have been given the volume of the solution of sodium hydroxide to be 250 centimeters cubic. Then apart from that one, we also have been given the mass of sodium hydroxide to be 2.0 grams. So this question is requiring us to calculate the concentration. And we have the volume, which is this one here, but the number of moles here we don't have. So let's find the number of moles. So the number of moles is given by the mass divided by the molar mass, or we can say the mixture, which is the relative atomic mass. So in this case here, the number of moles is going to be equal to the mass of sodium hydroxide. It is this one here, which is 2.0 grams. Then, so the relative atomic mass of sodium hydroxide, it is 40. Now we are not going to get the relative atomic mass, but we need to get the molar mass of this sodium hydroxide, which is going to be 40 grams per mole. Then from there now, gram and gram, they are going to cancel each other. So when I divide, the number of moles are just going to be 0.05 moles. So this is the number of moles that we are going to use now to calculate the concentration. So the number of moles. Okay, so like the way I was saying, concentration is given by the number of moles divided by the volume. And concentration sometimes can be also called the molarity, which is represented by capital letter M. So we have the number of moles here, which is 0.05 moles divided by the volume. So I was saying volume here should be in decimeters cubic, and the moles should be in moles. The number of moles should be in moles. Then the volume should be in decimeters cubic. But as for this one here, it is in centimeters cubic. So what you need to know is that 1 decimeter cubic is equivalent to 1000 centimeters cubic of volume. So which means for us to convert this one here, which is 250 centimeters cubic into decimeters cubic, we are going to divide the same volume by 1000. So we need to say volume now is just going to be 250 centimeters cubic divided by 1000. So our final volume here is just going to be 0.25 decimeters cubic. So this is the volume that we are going to use. So when I divide here, so we are having 0.25 decimeters cubic. Then the final answer is just going to be 0.2. And concentration is measured in mole per decimeters cubic. Or you can just say M, which is going to represent the molarity. Now here we are saying we need to calculate the concentration in mole per decimeters cubic. So that is our final answer. Thanks for watching.